Welcome back to my channel. The given question is solve z raised to 5 equals to I. What is I? I is a complex number, or you can say it is iota. So it has value I square equals to -1. Now this will solve by demoivre's theorem. Now what is demoivre's theorem says? Cos of theta plus I sine of theta raised to n is equals to this n I can bring over here, cos of n theta plus I sine of n theta. Okay. But be careful, this n should be what? It should belongs to integer. Then this formula you can apply. Okay. If n is a rational number, then what to do? If n is rational number, for example, if we have cos of theta plus I sine of theta raised to say p by q, then you cannot directly substitute. So we have some steps. Step 1 is what? Add twice n pi to the argument. Here we have argument is what? Theta. Okay. So in this theta, here we have theta. In this theta, you have to add twice n pi to the argument. This is step 1. Means what? Step 1 says cos of theta plus 2n pi plus I sine of theta plus 2n pi. This is first step. Whole we have p by q. Now second step is what? Second step is this, bring this p by q over here. Okay, like this you have done in this for n equals to integer. So let's bring this p by q. We have cos of theta plus 2n pi, and then you have p by q. Let's do second bracket plus I sine of theta plus 2n pi p by q. Now let's use third bracket. Now step 3 is, now you have to substitute the value of n. Okay, up to here value of n you substitute starting from 0, 1, 2 up to what? Q minus 1. What is q? Here this denominator q. Okay, now if it is 5, then you have to substitute 0, 1, 2, 3 up to 4. Okay, so you have to, and then therefore you will get the roots, or you can say values of this. Okay, now if I apply over here z5 equals to this, it means z equals to I raised to 1 by 5, I can say. Okay, so I same as I can write, this is same as cos of pi by 2 plus I sine pi by 2. Let's check whether it is correct or not. Cos 0 is 1, cos pi by 2 is 0. Okay, 0 plus I into sine pi by 2 is what? Sine pi by 2 is 1. Therefore this is same as this. We can apply demoivre's theorem over here. Now this case is not valid over here. Okay, here we have 1 by 5. Now this case, now rational number. Now if this rational number, what is step 1? Step 1 means what? Add this twice n pi to the argument, or you can say to the angle. So step 1 is, this is same as cos of, what is this? Twice n pi. Twice n pi plus pi by 2. Pi by 2 we all have. In this we have to add this. Okay, so this in this argument I am adding this plus I sine 2n pi plus pi by 2 raised to 1 by 5. Now this step 1 is over here. Here this is step 1. Now what is step 2? Step 2 means what? You bring this 1 by 5 inside. Now step 2 means here we have cos of, now before bringing this, so what I will do, can I take pi by 2 common over here? Now if I take pi by 2 common, then 4 n pi plus 1 into pi by 2. Is it correct? Now if I multiply this over here, 2 2s are 4, here twice n pi. Okay, therefore this is same as this plus I sine of 4 n pi plus 1 pi by 2 raised to 1 by 5. Now apply second step. Second step means send this down. Okay, send here, this here also, here also. This is angle. Okay, this angle for cos, this is angle for sine. So this is same as cos of 4n pi plus 1 is 1 by 5. So I can say 1 by 5 I am bringing, okay, here pi by 10, 5 to the 10 plus I sine of 4n pi plus 1, I am bringing here pi by 10. Now step 3. Step 3 means what? You have to substitute n equals to 0, 1, 2, I have to go up to 4, 3, 4, okay. So what is this? Here q minus 1, here we have q is what? 5, 5 minus 1 is 4. So I need to substitute n equals to this in here, okay. Since z5 is there, so we'll have 5 values of z. Let's substitute n equals to 0 over here. When n equals to 0, we have cos of this pi by 10, okay. Here we have cos of pi by 10 plus I sine of pi by 10. This is one value. When n equals to 1, we have cos of, so if I am substituting what, n equals to 1, 4 pi plus 1, 4 pi plus 1 pi by 10 plus sine of 4 pi plus 1 pi by 10. So you have, similarly you will get all values of up to here 4. Okay, these values of n gives the values of z's. Okay, so all values of n equals to 0 to 4 gives the roots or values of z. Okay, this is the answer.